So exercise 1102 is still looking at taking a sample and using that sample to perform statistical calculations. And the statistical calculation for this first example that we will look at is the mean. And we're going to see, now this is a really small population. They're calling this, there's only 4 results there, and they're heights of 4 people. They're calling that the population. And then they're going to ask you to think about the samples that are possible to form, just samples of 2 people. So we will do that. Now, based on our sample of 2 people, we'll calculate the mean. You'll see that some of the samples are very poor samples. There's one sample that's not too bad. Its mean gets fairly close to the population mean, and that's just the mean of those 4 numbers. And we'll see also what you can do to improve your statistical result if you feel like your sample wasn't the best. And it's probably in reality what researchers do anyway. They don't base a recommendation just on one sample. So what we're going to see here is we're going to create quite a few samples, and then we're going to see a very interesting fact that comes out of creating enough samples and how we can get the actual population mean from samples. Now, I suppose that's not always going to be possible. If the population is huge, then you wouldn't want to have to create enough samples that you cover all the population anyway. You might as well have done a census. But what you will see is that the more samples you test and develop some statistics for, and you take those statistics from the different samples, then you're able to use those statistics and maybe average those and get results closer to the population's mean or standard deviation or whatever it is that you're wanting to calculate. And this is all based on the idea that really in our sample or in our samples, we want to get results that actually produce or reflect the whole population. Because that's ideally what a good sample will do. You've created a sample, or you've created several samples, and in the end, when you average out your results across your different samples, you're getting very close to the statistical calculation for the whole population. You know that the symbol we use for the mean is this symbol. And if we're getting the mean of a sample, then we will commonly use that symbol. If you're getting the mean of a whole population, you use this. It's a Greek symbol. We call it mu, and it's this shape. Now, you're going to be getting the population mean because the whole population is just these 4 people. And we're going to be creating samples as well. I might pause the video because I think it'll get very long, and write up some of the solutions now for the samples and their means, etc., and then come back and talk to you about it. Okay, I've done A and B. A says list all possible samples, and remember the sample is just to be of 2 people. So samples of 2 people, so we could have Anne and Bella, that's 1 sample. Now if you have a look at that, Anne and Bella, Anne is 176 centimetres, 178 is Bella, Chris is 180, David is 184. So they're in order, shortest to tallest. If we formed a sample and we know that the 2 shortest people are in that sample, then we know really that sample is not a good sample. That's not representing the population. Well, the population's not that many here, but the population is made up of male and female and short and tall people. So clearly having 2 females, both short, would not be a good sample. This sample does not reflect the entire population. Anne and Chris, again, well, at least it's a male and female, and still got the shortest and the second tallest. It's going to be better than that sample. Anne and David, well, they're the extremes, aren't they? This is the very shortest, this is the very tallest. How well is that going to tell us about the middle? Not so sure. At least one's male, one's female, so I think it has that in its favour. Bella and Chris, as you'll see when we actually do some calculations, works out to be the best, or the closest, have the closest average to the actual population average. Bella and David, second shortest and tallest, is okay. Chris and David certainly is not a good sample because they're both male. They both have the 2 of the highest, tallest people. Their average is going to be quite high, especially compared to the population. B says calculate the population mean. So the population mean is this: add up the 4 numbers, divide by 4, and you've got 179.5. Like I said, this example is not very realistic. You wouldn't need to be forming samples and doing statistical calculations on them when you've only got 4 people. Of course, you would just stop here and work out the population mean. However, the purpose of this question is to show you that we formed these samples. Some of them aren't very good. We're going to calculate the sample mean for each sample. So again, I'll pause the video, I'll do that, and I'll come back and talk about them. So you can see the average now from this sample says there's an average or a mean of 177. Now knowing what the population average is, being 179, we can see that no, this isn't a terribly good sample. This does not reflect, this sample certainly doesn't reflect the overall population. The same with Anne and Chris, 178. It's getting slightly closer. It is slightly better. Anne and David, it's also close, but it's a little bit above. Bella and Chris at 179 is the closest we get. Bella and David at 188, too high. Chris and David at 182, also too high. So the majority of these samples don't reflect the population. So on their own, we wouldn't be wanting to take, for example, this result, use it on its own to make predictions about the size of a seat. If we're trying to work out, gather information about the average heights of people, determine the seat height, this sample would not be very good. Now, what is really interesting is, and this only works because we have covered every possible sample of 2 people that covers that whole population. Now, that was possible because there were only 4 people in the whole population. But if we're wanting to get information about 20 million people or 24 million people, whatever our population in Australia is, we're wanting to get information about that. We're not going to be able to form samples of a smaller size that then is going to cover everyone in that 24 million. So I guess what we would be able to do in reality is at least use more than one sample. Gather data or form a sample, get data from it, perform some statistical calculations on that sample, but then form another sample at another time. Perform your same statistical calculations and then maybe average your 2 results. So the more samples that you could produce and analyze and take the results and average them, the better, or the closer you will get to what is happening in the whole population. Well, interestingly here, and it's because we've covered the whole population, if we add that up and divide by 6, and you can do that, you will see you get exactly 179.5. So even if your samples are not good, if you can create enough samples and perform statistical calculations on every one of them, that if you could form enough samples to cover the entire population, you would end up with the same statistical calculation as you get when you apply it to the full population. That's all this example is doing, and it's really just to reinforce you want your samples to reflect the entire population, and if you can't get that, then you need to use more than one sample before you start making conclusions based on your statistical calculations.